Hello everyone. Let me introduce myself. This is Asafi. We are currently at a class BANA 8395 analytical practicum, and our professor is Dr. John Colliers. Um, I will thanks professor for all his hard work and during the class sessions and outside of the class, helping us prepare for our practicum in this final presentation. And I will thank everyone who was involved in it. Uh, I have this presentation on breast cancer, Wisconsin, and it's a predicting cancer as a malignant or benign cell. I have a very personal emotion attachment to this topic because my mother was diagnosed with stage 4 breast cancers, and that's for her, and that's why I wanted to do this. I chose this data sets so that I could better understand about the cancer and how to find it and how probably could help other people to do to survive it. Uh, So my presentation is I have created it the way that I will be giving some backgrounds and what will be my objective, what will be methodology, data source, data processing, analysis, analytical procedures, deliverables, and the timeline I have chosen for overall the my project that I was doing it. Background of the project is that I will be creating a machine learning models where it will be predicting the benign cells and malignant cells. It's the second in the breast cancers diagnosis where the patient is already diagnosed with the cancers. It's now then chosen with tumors, and it's now then choosing either it's a cancerous tumor or it's a just benign cell. So a little bit about uh, breast cancers. Breast cancer is a very common in women's, and it's getting increasing a day by day, and that's why it's been declared a public health problem. The survivability of the breast cancers is patient is very important on the diagnosis, and the time of diagnosis is when that happens. The earlier the diagnosis, the greater survivability chance for the patient to survive that disease. And there's a various machine learning models is created for that to go into that to the data and look for pattern recognition and find that what type of cells is malignant cells and predict it very accurately. So in order to detect the tumor at the very first stage is the mammography is used, and it can detect the tumor before even it turned out to be. And the women from age to 45 are an average risk, and they have to do one mammogram a year. A woman at 30s at higher, who those women that they are in a high risk, they have to do an MRI and early. In risk factors is that the older the women's get, there's the more increased chance to getting into breast cancers. And other factors that they could affect is genetic factors, and childbearing and menstrual history could cause the breast cancer. It could create an issue. So objective was to find out what percentage of cells are malignant in this data sets that I have choose, and what percentage of cells are benign. And by malignant, those cells that they are out of shape and they are about to turn into a cancerous cells, it's called malignant cells. And those cells that their shape are good and they have no chance of turning into a cancerous cells is called benign cells. So then I need to build a model where it could early diagnosis of breast cancers, and that model could predict at a high accuracy, and also could classifies those cells, and could find out on the basis of those benign and malignant cells. It's a very it's very important to find out either the cells are benign or either the cells are malignant, because if it's a benign, then we could avoid unnecessary treatment, or if it's a malignant, then it's the patient's survivability matter. The methodology I use to build this machine learning model is following. So I will be creating a machine learning model that will classify the cancer cells by benign and malignant. And I have also did some descriptive analysis to explore my data sets where I could find a missing value. I had to drop an ID column where it doesn't necessary for us. And I had a diagnosis column, which is our Y variable or independent variable, and has a M as a malignant and B as a benign, and I change M into 1 and B into 0. I have split the data sets into 75 and 25 for training the machine learning model and then testing the model. I use the training data sets to develop the supervised machine learning model. I use those several supervised machine learning model for the logistic regression, random forest, forest, decision tree, KNN, support vector machine learning, and naive Bayes. And then I will be um, checking their performance on the basis of classification report, confusion metrics, and accuracy. My data source is called the Breast Cancer Wisconsin, and I have a link here which I pick up the data source from in predicting the cancer as a benign or malignant cell. My data sets contains 569 rows and 32 attributes. It's actually 33 attributes, but since I dropped the one, it's a 32 attributes, and we do not have any missing value. And as I was looking into the data, so that we have a diagnosis column where 357 of them are B, which is benign cells, and 212 are M, which are malignant cells, or those cells that they will be turning into a cancerous cell. Uh, Data processing features and engineering. This data set was created by Dr. William H. Welberg, physician. He's a physician at the University of Wisconsin, and he created this data sets, and he used a fluid sample for a patient with a solid mass in breast. As I earlier mentioned, that this data sets were created from those patients that they were already diagnosed with some sorts of tumor. So and they use they use the scan using X-SAST algorithm, and this is a very useful algorithm where they measure the distance of the image, and it could predict at high accuracy. This data sets will be divided into two sets, 75 and 25, and I was looking to predict at 98% of accuracy, because this is a medical field and it's people life depend on it. And for data processing is that I had an ID and diagnosis column, in which are B and M, benign, the diagnosis college had, and I had to drop the ID column, which has no data and didn't help us. And other informations about the data set is the radius, texture, smoothness on competency, and symmetry of the fraction dimensions about the other columns, that they are independent variables to the diagnosis variable dependent. This procedures will be happening in a 4-phase. Is the number one phase. Number one will be the data exploration. Is that I have a 569 rows, 32 columns, where M is malignant, B is benign. And phase 2 will be categorical data and splitting the data sets, 75-25, and I have used a Python for that, and scikit learning library that I split the my data sets. And for all the machine learning models, scaling is very important. I have used the feature scaling to scale my data sets either from 1 to 10 or 0 to 1. Here I chose 0 to 1 because it's more we use medians and means, so I have chose 0 to 1. And then the model selection will be the phase 4 will be a model selections, and what will be the best algorithm that could predict at highest accuracy. Phase 1 is a breast cancer, and I already do explain that how many rows will I have, columns I have, and this is a snapshot of my data sets, and I have no null values in my data set. And this is my data exploration in a histogram, where it's not scale data now, so we need to scale the data set so we will have a much better bell shapes histogram of our data sets. And then handling a categorical variable, since my data sets has a B and M, I have changed that into a 0 and 1 because the algorithm can deal with the numerical values very easy than M and B. And then I have used that 0 to 1 scaling. Use the Python scikit learning library, and I scaled my data sets to be it's a 0 to 1, much better for an algorithm to understand it. And then model selections, I have choose the 7 models and run my data sets on to see which models will be giving me the highest accuracy. I have used logistic regression, nearest neighbor, support vector, kernel, naive decision trees, and random forest models. And the model selection was happen into classification, confusion, and accuracy. These were the reasons that I have chosen the model. And my model turns out to be the best model was the random forest classification model, which was predicting at 98.6% accuracy. And I have chosen this model. I was looking to do possible much better than 90%, but it actually turned out to be 98%. The second best model was the support vector machine model, which was producing at 97.2% percentage model. And the my timeline for my project was to finish it, and today is the final phase of presentations that I was doing to finish it. And I have chosen the random forest model, and there's no surprise that this model was producing at high accuracy because this model is uh, changing a data set of decision trees based on median, average, and it'll choose that. So that's why this model was producing at high accuracy. Thank you everyone for watching the presentation, and if you have any questions, please feel free to ask. Thank you, professors, and thank you everyone who helped me around. Bye.